Sorry, I covered up the bunny there. No. How's everyone doing today? Everyone having a good morning, good afternoon. I think Mohammed wants some questions for assignment 2 for 320. So, which ones are you working on, Mohammed? Which ones are you working on for assignment 2, 320? So, assignment 2, 320, which questions are you working on? Which questions are you working on? Who has questions? We can hop over here to the main screen. Who has questions? Who has questions? We see we are live, right? We should be live. If you have questions, go ahead and ask them now. It looks like we are live. We should be live. Who has questions? We got a bunch of people here. Ask the questions if you got them. Can you 4C for 474? Yeah, Sean, let me pull that up right here. So I need to do the good old two-factor stuff. So one moment as we get everything booted up right here. 474. Let's talk some 474. That is the first question. So feel free to mention, hey, Brian, can you go over this question right here? And we shall do it. We shall talk over the questions. Okay. So let's see. 474. I'm pulling up the assignment as we speak. Let's see where we get to. Homework 2. And let's download. We are downloading. We are opening. And we are good to go. Let's do this right here. And lots of questions. Awesome stuff. Let's do it. Okay, we are in assignment 4 right now, and we're talking about 4C for 474. So let's put some notes on here. Let's put a note. So 4C for 474. So we got right here. Lots of questions. What do I do if when I run library arules, it says there's no package called arules? Amanda, do the following. Install.packages. arules. There we go. This should do it. Is arules spelled that way? I'll find out the hard way. Well, we don't want to install it again. No. There it is. So this should do it right here in the chat, Amanda. There you go. That'll install the arules package. And I see a lot of great questions from David and Parker. Parker, we'll go back and we'll do that question here. And David, I think, was next. So Sean, you got it. Sean's first question is 4C. And sorry, it jumps to question. 4C is this one down here. Okay, let's talk about this right here. Okay. So we have, where's 4C? There's all the stuff right here. Let me run all the code above it. Okay, good. We're going to look at the rules right here. This is a really good review. And since this can be on the test, no worries, no worries. Great stuff right there. I'm going to basically talk about how to read this code right here and what's the importance. So if you remember from 320, statistically significant means that what we're seeing here is unlikely by random chance. And so when we see if all these rules are significant, it's just telling us that all these rules we made are statistically significant, i.e. unlikely by random chance. Now I'm going to take some of these rules right here and go over the meaning of them. So this is a really good review of how to interpret rules. And I might go over like a rule that's not your rule. Let's go all the way down to here. Okay. So this does have coverage, which is something we don't have in our notes. Don't worry about coverage. I don't use it that much, so it won't be on the test. Good news there, won't be on the test. So do not worry. Now, with this right here, let's take a look. This is a lot of output. But let's talk about your inspect rules doesn't run Park. You might have to email me. Run all the code above it. Run all the code above and then run the current chunk. And if it doesn't work, email or Discord me. But definitely let me know if it's not working right there. But double check. Everything should work. Everything should work. So with this right here, let's see. We have all the different rules. And how do we read this right here? Who knows going from left-hand side to right-hand side, going from left-hand side to right-hand side. Make sure to run all the code above and then run the rules. And it should be set up to work. So how do we read this right here? How do we go from left-hand side to right-hand side? How do we read this? Let's put it in a comment box, text box down here. So how do we read this? I need to make this go behind the text. Through text. That should work right there. There, that's great. Perfect. So, who knows? No one knows. Oh no. Given given blank is missing. So given this is missing, let's copy this. How does it impact blank missing? So who can tell me? So this is how this works right here. Given blank is missing, how does it impact blank missing? Given blank is missing, how does it impact blank is missing? So trying to fill in the blanks right here. And no, wait. Whoa. I was on the, there we go. That was weird. So try to read this rule right here. Try to read rule 8. Who can read rule 8? I'm going to pause. I want people to try to read rule 8 right here. So who can read rule 8 using this format right here? Like this is probably one of the best ways to read, I think, to be like, okay, left-hand side, right-hand side. And we'll use this again when we do market basket analysis. So watch out if you're in 474, when we do market basket analysis, it'll be like, given someone has this item, how does it impact the probability of them having this item? So we could say, you could say probability, or how does it impact? How does it impact? Because one of them will deal with probability. So I need someone in the chat to tell me for with 100 points. Finally got some time to get into, yes, Alex, feel free to ask some questions. We're putting all the questions up here, Who can interpret this rule right here? Because this is 4C, I think. 4C. C4, 4C. Who knows? How do we interpret this rule? If merchant is missing, well, Marissa, you're on the right track. Great job, Marissa, 100 points right there. So given merchant is missing, how does it impact high missing? And I think you're right, because great job, another 100 points worth right there. You went right to the confidence. And the confidence tells us the probability. So let's put a note right here. We can put another one of these boxes. So we're going to put this box right here. And we're not doing the exact question. We're just doing similar stuff. And so let's put this right here over confidence. It's going to get pretty crowded here pretty quickly. But we'll put like an arrow down to it. Okay, so the confidence is probability. And this would be the probability the right-hand side is missing. So this right here is what Marissa was mentioning. And this is the probability the right-hand side is missing, is the confidence. So the confidence is the probability the right-hand side is missing. Can't say that enough. Let's put that right here. And so that is the probability the right-hand side is missing. So given merchant is missing, then there is a 12.07% chance that high is missing. Now, what is the support? So we need some good notes in here for support. So what is support? Support is percent of time both are missing. So support is the percent of time both are missing. Who can interpret in a sentence what this support means right here? Just think of it as a sentence. And great job right there, Amanda, 100 points. Who can interpret what this support means right here? So support is the percent of time both are missing. So from the data set, blah, 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 blah. So from the data set, what? So from the data set, what? From the data set, what? Given blank is missing, how does impact blank missing? Oh, I was mad about the grammar. We'll ignore the grammar. Who knows? What does this support mean right here? What does this support mean? And coverage, I just never use coverage. So don't worry, it won't be on the test. I'm not going to put it in here lest we distract people. What does this support mean right here? Both blank blank are what? From the data set, there is a you're right. So both in the data set, merchant and high are missing 2.89% of the time. So in the data set, we're missing the values of merchant and high together. Like this would look like if we had rows right here. That's the wrong drawing pen. If we had rows and there was like a merchant and there was a high, good. It would mean that we would have missing values. Like here's what it means to have a missing value for both. It'd be a row like this where there'd be NAs in there if we looked into the data. Does that make sense, Abby, right there? Like this is what it means. Like they're missing both. Like that's a merchant column and that's a high column. And then this is a row where we're missing it. So 2.89% of the rows are missing both the value of merchant and high. So 2.89% of the rows are missing both values. Not like this wouldn't count right here because it has one of the values, but 2.89% of the rows in the whole data frame are missing both values together. Like it's missing this value and it's missing this value, not as in like they're missing like a total, like not the total NAs, but the total percent of rows that are missing both. That is what exactly we're talking about here with support. So the support right there is 100% what we're talking about right here. I'm going to circle in spacepen for the moment. This support stands for the percent of rows that are missing both. Oh, what's up, Connor? Talking about some a priori learning right here. We got it. Connor, do you remember coverage? Because that was like a new thing they just added in, but it won't be on the test. So we're not going to talk about it. So I don't want to confuse people. Lift. What is lift? Lift is going to be the factor increase from the naive probability or the original support of the right-hand side. That's a lot right there, right? That is a lot to say. So lift. So the percent increase to the probability, it's a lot. The percent increase to the probability of the right-hand side missing, giving the percent, I should say change, or the factor change. There we go. The factor change to the probability of the right-hand side missing, given the left-hand side is missing. So it's a factor change. Very important right there. It's a factor change. We don't want to do that. There we go. So many typos. So many. This just doesn't like it. No. The factor change. There we go. It is the support of the left. It is? Is that all it is? Or you guess it is? Or is it really? Is the coverage the support of the left-hand side? So is that all it simply is? Because we don't include it on the test, so I don't review it. So I'm like, what, you know, like, don't worry. Like, I don't want to put it on here unless people... And it's not that hard. You know, we can find... I can find the left-hand side support. If it's just left-hand side support, I can find that really easy because we should be able to look at the... So I'll show a few things here real quick. This right here, the last thing right here, the... oh, shoot. We're blocking the view of it. There we go. The lift, which that is right there. And then the count is the amount of rows that are missing both. So the count right here is going to be number of rows missing both. So the count is the number of rows missing both. So this should be a really good breakdown of this, especially for the test. Like, if you're looking for a really good review for the test right here, what do you think of this, Connor? Like, get that off the screen. There we go. I think that we couldn't ask for a much better review of all the concepts than kind of labeling them out like this and kind of making it as clear as possible where everything's at. That as you go through here and you look at what all these different things are, there's 3,655 rows in the data frame that are missing both coverage, cover left-hand side support. Oh, it is? Was this left-hand side support? So what we should be able to say then, if it's the left-hand side support, then watch this. Let's go here, and it's I can tell you how many rows are missing then. So it's 0.23942748, and then we should be able to go to our data frame. And the data frame we are working with is the by 2 data frame. By 2 has this many rows. Why am I typing it in a calculator when I have R? So we go here, and this is left-hand side support is equal to this right here. And then we times that by the number of rows in by 2. And n rows. Wait, new function. Oh, it's n row. And then we times that by left-hand side support. And there we go. And if we do this, is dot NA by 2, and the thing was merchant, right? So if I go to 2 and go to merchant, I think it was merchant, there's a vector of true falses. And if we go to sum, is that right? Yeah, that's got it. So there we go. They're the same. Yep. So I want us to look at this right here because this is, and that'll be true. Oh, it's false. It's because of decimals. How dare you? Let's go to round. There we go. It was decimals in the background that we couldn't see. It was carrying it out way further, and it's like, no, that's not exactly the same. It's like, come on. If we round it, it's the same. And as in, if you notice right here, the numbers, I don't know why it's carrying something in the background we're not seeing, but now since I rounded it, it says it's the same value. So this right here, we just had to round it a little bit because there were decimals carrying over, is the same value as this right here. Now I want to point out the importance of this. What Connor told me is that this right here was the support of the left-hand side. So there's an important terminology right here that's really going to help with reading these rules. The support of the left-hand side means what? The percent of time that the left-hand side is what? The percent of time, you bet. We're going to do some 320 next, Alex. You got it. The support for the left-hand side is the percent of time that the left-hand side is what? Because this is the support for the left-hand side. It's the percent of time that the left-hand side is what? The percent of time that the left-hand side is what? What does support mean? The percent of time that the left-hand side, look at this is the percent of time both are missing for the support for the rule, and the support of the left-hand side is the percent of time that the left-hand side is missing. So when we talk about support, there's 3 supports you should know. There's support for the rule, which support for the rule is right here. So be very careful. This is where people make mistakes, especially later on. You've got support for the rule, and you have support for the left-hand side. We'll go right-hand side because we usually care more about that. And support for right-hand side, left-hand side. So the 3 supports here are how often are both things missing in the data set, how often is the right-hand side missing, how often is the left-hand side missing, and that's from the coverage right here. Now, I have to go to work soon. Can you go over the video, go over some label the bar charts by hour to minute? Yeah. Awesome, Marissa. Yeah, we can do that. We can label them. You got it. We can do some labeling. You got it, Marissa. And so we'll do another 474 question, I think, because I think that might have been the other question people had. But does this make sense right here? I'm going to put one more big note on this because this is almost like a cheat sheet for like reading this output. One more big note I want to put right here. You're welcome, Marissa. Is that, I'm going to have to write this and I have to like be careful because my handwriting's horrible. Okay, so we've got it figured out right here. Can anyone tell me, I'm making this a 1,000-point question for the week. 2D, oh, you got it. Let's do 2D next. We'll do 2D and then we'll label some graphics and we'll hop to some 320 next. Can anyone tell me the support for the right-hand side? Because here's a hint. Here's a hint. Check this out. Do you currently have both this and this? Oh, send me your file, Connor. Send me your file, Connor. I have no idea what's going on with that. That sounds odd. See if you can solve for the support of the right-hand side. This is a very common test question. Test questions like this are very common with this because it's an algebra question, but yeah, send me it on Discord and I'll check it out. Can you solve right now for the support of high right here? Can you solve for the support of high? Who knows the support of high, which is the support of the right-hand side? Who knows what the support of high would be? And you can kind of cheat because it's on the screen somewhere. The support for high, if we backwork it, and so I'm going to have to zoom out a little bit here. If we backwork this, we flip it, and I think that'll do it. And then it'd be, so we times by confidence. Okay, I think it's going to be, if I do my mathematics correctly, it's going to be let me think if that makes sense. Yeah, you're delifting it. You're delifting the confidence. That makes sense. I call that delifting the confidence because you're dividing the confidence by the lift. So the lift is the factor increase. So let's take the confidence in the rule right here. So let's go to the confidence in the rule. The confidence in the rule is this value right here. And then I'm going to take And I'm going to divide this by the lift of the rule, which is this right here. Then I'm going to solve it in my head. Let's try to solve it in my head. It's going to be about 0.030865. 0.030865. Oh, wait, what did I do? Let me check this out again. I typed in something wrong. Oh, I chose the wrong value. I chose the coverage. No. Let's try that again. Because that's why we look and use output to help us. 3.913249, and this should be 0.030865. There we go. There's the value. And how did I get that, Connor? With your help, I was able to see that the coverage up here is the support for the high. So I was able to figure out the, or no, this one right here. There it is right there. It's, oh, no, it's the right-hand side. Yep. And high and low are missing together. That's why they have the same coverage. If you do this assignment, you'll see high and low are missing together. But the support for high is the coverage right here. So knowing that, I kind of used it to cheat. And wait a minute. Yeah, that's the support for the right-hand side. Oh, and it'd be the left-hand side. I'm so not used to using coverage. So I should be looking at the second rule because does that make sense, Connor? And if anyone else is noticing what we're doing, I should be looking at this rule because the coverage is the left-hand side support. So let's put a quick note down here. Last but not least, one more note. This right here, we don't use this much, but this is going to be coverage. Oh, that's horrible to see. This right here is the coverage. So we got everything covered. Does this output make a lot more sense to everybody right now? Do you understand what's going on with this output? This is like a mega cheat sheet for everything. Like, so this is how to read all this output, every single thing on here of all the importance that you could be tested over. Do people feel better about this? We're going to go over to 2D here in a second. And then we're going to make sure we do we could probably do 2C and then 2D, and then we'll hop to some 320. I think that's got it. It's so easy knowing. And I think I'm looking over the questions. 2D, a lot of people 2D. And 1C, Jake. 1C, Jake says, let me look at 1C. We might have done another video, so I might not. I always try to cover as many questions as I can. And then I do some fully or some in part. So 1C. Did we do this one yet? I don't think we've done this in video. Let's do 1C. Okay. So with 1C right here, and let's talk about it. I might not do this problem in full. I might explain it a little bit. Make a character vector called bad levels that contains the offending levels. So what we want to do is we want to look at the names, and I'm just going to kind of allude to this one a little bit. We're going to go to the by data set with a capital Y, and we're going to go to the names. There's no names. Oh, because haha, it's levels. So we want to go to the levels of the by name. Now, here's the thing. Everyone knows we code in little bits. And with these little bits right here, what are we going to do? We're going to find the offending name. And the offending name is actually at the start of it. There's only one offending name. And so we can get the first few names and we can see if something looks weird. These are the names of notebooks. Does anyone see a notebook name that looks weird here? Like, what? 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 Does anyone see a notebook name that looks weird here? And I might write down the steps to do this because I don't want to give away all the answers. So it wants the total number of bad names in the original data. There we go. Spell check's in there now. And it wants fraction of bad names in the original data. 404 not found. Boom. So let's grab that one right here. And now we can store this into something. Nice job, Jake, right there. So we're going to go here and grab this and store it into this right here. So does that make sense that when I put this 1 at the end of it, it only took the first value in that vector? So I threw some square brackets at the end of it, and I said only grab this first one. Before I had it returning all of this, then I said nope, just the first one. So now bad levels, you can check, it's just that level right there. So there's lots of ways to do this. It says a command that prints out the total number of values in the name that are, so like, if you think about this, prints out the total number of values in the name column which are bad. So I'm trying to remember, like, how do we have this right now? Value that prints out, another command prints out the portion of values in the name column that which are bad. I'm trying to think, could I save it into 404 not found? Yeah, well, I wouldn't save it into that. I would call it bad levels. You wouldn't want to save it into a string either. So I don't know. I don't think it'll save into a string. Yeah, that should work right there. Oh, and then make sure, Abby, to put a C before it. So as long as you put a C, it should do it. Oh, MuBot, didn't even remove it. What are you doing, MuBot? What do we pay you for, MuBot? Tell us what we pay you for, MuBot. You tell us. You tell us what we pay you for. Yeah, you are MuBot. So it's supposed to like remove it, but it must not have permissions to do that. So Bot doesn't work as bot should. With this right here, it just thought you were posting like a link with like the slashes and quotes, but I made you a mod, so don't worry about it. And don't listen to me, bot. He doesn't know what he's talking about. So with this right here, we're storing it into bad levels, total number of bad names in original data. And so there's two ways to interpret this, like how many of the names are bad. And when you think about this, I'll kind of do this one. If you get points off, tell me. I think I might have told one person differently on this. What we want to do is we want to look at the names right here. And you want to see this, but we're one step away right now. What will this code right here return? What will this, think about my code I've written, think about what it will return, and then we're just one step away from getting to where we want to get. And I might not do that last step. Don't put this code in what you have. This code will be very, very bad. So what would this code do right here? Like, don't leave this code as is. I'm trying to do more where like you have to watch the video to follow along. Like you have to watch the video, you have to follow along. You have to be like, okay, what do I do next? Brian put me right here, and then I have to like finish it. Like it's a new way of teaching me to be like, here's me kind of doing the assignment on a video, because it's like it's hard to like help if not. My hair's just getting really long. What will this code return? Who knows? No one knows. 320 is like, no, we have to get to us 320. It's a logical check. What will it return? Logicals, Connor, you're right. Boom, you'll flood the screen with logicals. So if we want to, it'll print a lot of falses, but you could, why not? I'll be nice today. You could find out how many trues there are, and there you go. That's how many values there are, because it says, and please tell me if I misdirect anybody, a command that prints out the total number of values in name column, yeah, which are bad. Another one prints out the proportion of values in the name column, which are bad. So then it just wants proportion. So I think you'll be all right from here. Like, I think, you know, it's kind of an extension of this, which, you know, maybe change something right there. Maybe something right there to change later on for the next one. And I think we had, does that make more sense, Jake? I think you were asking about it, Jake. Does that make sense? It was your question, Jake. Are you feeling pretty good on it? So hopefully, are those the only bad levels? I think so. It's the only notebook which has, yeah, there might be, I don't think there's other ones. And this is actual Amazon data from the buy box. You're welcome. And if I ever tell you anything and you get something wrong, tell me. Be like, Brian, you said this. Sometimes someone will listen to me improperly and they'll be like, Brian, you said that, you know, like histograms are categorical. And then I'll be like, when did I say that? And they'll be like, oh, I looked in it. You said quantitative. I'll be like, okay, good. And then someone's like, Brian, you said histograms are categorical. But when did I say that? And they'll show me the video. I'll be like, oh my gosh, I did say that. I mean, I make mistakes. I mean, usually I'll just accept if you say I said something wrong. I'll be like, I guess I did. Unless like you're like saying it every day. I'll be like, can you show me where I said things wrong? I'll usually take your word for it because I make mistakes too. Okay, not about me making mistakes. Let's not make some mistakes right here. Let's do this. Let's go and start the lubridate library. And the first thing with lubridate, step one with lubridate, then we're gonna hop to some 320. Step one with lubridate is to do what with your data? Step one with lubridate is to do what with your data? I'm sure Connor knows this. Connor, you're the all-star right now. Whenever you're working with lubridate, put Connor on the spot right here. Whenever you're working with lubridate, what do you have to do with your data? What do you do with your data whenever looking at lubridate? Oh, you use lubridate? That's awesome, because if you use lubridate, it's for all the date time stuff. Like anytime you have date time. And the first thing you must do with lubridate is figure out the format. What is the object of the date time exactly? So maybe you have something like this, where I wonder if this will work. I wonder if that'll work. Let's try that. Okay. Let's try this. Dates, concatenate vector. I don't think this will work. Let's find out. This is in month, day, year, dates. It didn't like it. It needs Jan right here. Now I'll do it. It doesn't know J. If you write the format, you can write January. It'll parse the text now. I wonder if it can do it with a typo. Can't. Which is kind of a bummer. It has to recognize, and you are correct, Connor. This one, right? This is month, day. Oh, yeah, no, this one's month, day, year. And then this one is right here. If you go down to one of these, you can see it's year, month, day. Year, month, day. So this one right here is year, month, day. And so that'll actually parse. If you go to this vector right here, and we want to go to buy, $, buy box time. And one, you should print it, look at it, notice the format. And the format is in year, month, day, hour, minute, second. So we're going to go right here and go year, month, day, hour, minute, second. And we're going to take this right here, and we're going to put the same vector, and we're going to overwrite it. Boom. Got it. Yeah, lubridate's really good. Year month day is the one you used yesterday. Yeah, it's really easy to just like pull up one of these functions, boom, run it, got it, good, excellent stuff. And now you know it's worked if you go to this vector and you run, well, one, run your vector. Don't leave this on the screen because this will create excessive output. But two, you could check the class of it and it'll give you the position X time on it. And Connor, how often do you run something and then look at this? Because Connor's been coding a while right now. And Connor, no, I remember you sat in the back at 320 and then you had coded before this. You had coded some Python, I think, before we took 320. How often do you run something and then look at the output? Do you usually run it and then just like say, it probably did something? Or do you run it and then like look at the output? Yeah, output all the time. You have to look at your output. You have to be like, oh, what did that do? Yeah, structure can get, you should be able to get the structure of that, right? Yep, there it is. And it gives you a preview of the file. So we could get the structure of this. Connor, you know about dplyr, right? Because dplyr has glimpse. Glimpse is a better structure. It actually does it formatted for your screen. So when you do glimpse, if your screen is like really small, it'll, whoops, wrong button. It'll format it for your screen. So glimpse is even better than structure because it'll format the output for your string. Yep, pipe tools in dplyr. Piping is awesome. And I should get better at dplyr. I just don't use it enough. Yep, it has mutate. Yep. And you can always check the dplyr by going up here and being like, what all is in here? Mutate. You can mutate stuff. I wish I knew all of dplyr. Data manipulation right there. Really great stuff. And now we're on to 2C. Okay, so I'm not going to do all of 2C right here, but I'm going to do a little bit of it. But anytime you want to make a bar plot, you have to give it a what? All bar plots must be given what? Who knows? Who knows? 100 points. Connor, you can get 100 points right here. Or anyone else gets 100 points. All bar plots must be made from this. All bar plots must be made from this. When I repeat things like this, it's because I sometimes forget it. Because I'll go to make a bar plot and it won't work. I'll be like, what's going on with this bar plot? All bar plots must be made from a table, Sean. 100 points right there. All bar plots must be made from a table. Now, what's really great about lubridate is all the functions like hour. If you put in your time object on here, which I think we made it from this. So here's the hour, the day, the month day, the year day. There's all these functions right here, and you could go and look at them. Great job, Alexandria, right there, 100 points, and Marissa, 100 points. So with this, you can pull out any information you want from the time object. This wouldn't work if we hadn't created the time object. You can go to the weekday. Now, things like weekday have names to them, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. You can go here, and there's an additional argument, and do label equals true. So now it's got the day of the week, and it's created an ordinal categorical variable. So now it's a factor. This right here, if you were to look at it, should be an ordinal factor. So if we go to class of it, it'll tell us this vector is a factor and ordinal. It's got two classes to it. It's an ordinal factor. That's just kind of knowing how R handles it, but we can also see it in the data right here that it's telling us the levels. And whenever it's ordinal, it reports it from least to greatest, kind of putting it in order. So with this right here, you might run into issues where you do things like year day, and it'll get mad at you, and it'll say unused argument. That's because there is no label for the day of the year. It's just the year day. And I don't know, it's called Y day for year day. It's called W day for weekday. Any ideas what M day is? Month day. And then I think day is month day? Oh, cool. Month day and day are the same thing. And then you could do week of the year. There you go. That's the week of the year it happened. So think about how easy it is to use this. You don't have to do all these calculations in the background. You have to be like, what week was this of the year? What day was this? Was this a leap year? You can actually see if things are leap years and stuff like that. I think is it leap year and it's a logical? It's my last thing right here because I never used this function. Leap year, and there you go. It'll tell you whether or not that thing was a leap year. So you could go through here and check to see if any of these are in leap years, which I guess they're not leap years. Yeah, I guess not. I'll double check. I don't use that function that much. So with this right here, if you want to look for things like make a bar chart for the hours, we're going to go here to hour. And then after you do this, you have to make a table. So we're going to go and take this and put this inside of a table. And we're going to close off our table. We got our table now. And now we can put the table into a bar chart. So we're going to go here to just plot, right? My brain suddenly hiccuped. Was I saying box plots? This is a bar chart. I think I was saying box plots earlier. Please, you see, we talk about Brian making errors. Mubot, what do you think of that, Mubot? Oh, well, that's going to tell me my errors. One more error to go. This is a bar chart. This is not a box plot. If I said box plot earlier, I was wrong. Bar charts need tables because I was literally just teaching box plots earlier. So, so with teaching, box plots, and we're switching back to bar charts. Bar charts are categorical. You see, box plots are quantitative. So you could take the whole vector and you can treat it as like categories right here, like what hour was it? Or you could say how many hours, because you can technically make a box plot out of this. So here we'll go to this, and don't make this graphic. It's unneeded, but you could make it into a box plot because it's quantitative. But you can also make a table of the frequencies. So the difference is right here is this is a table of the frequencies, and then you can take a table and turn a table into a bar chart. Where's my bar chart one? Did I lose it? There we go. And so this will do it right here. And if you want to add a title to these, which I think was one of the big questions Marissa had, Marissa, if you're still here, I think it was, how do you add a title? I might go back and look real quick. Don't put this into 2A. So title, is not title right there? We need to go to plot. Oh no, it's main. I'm waiting for Connor to say, because then maybe Connor's worked. It's main. It's not main? There you go, that's main. Main is the argument. I wish that auto-completed, but main is the argument to put a title on this. So I don't know if you can do a title color. You can make box plot colored. Favorite color, gotta know it off the top of your head, is FF8200. It's UT orange. So you can do fun stuff like this. Lubridate's going to be even better, but I think this should help out with, don't put title here on it, write a title. But this should help out with creating the visualization right here. And where's my visualization? It was under 1A, 2A. Don't put that under 2A. It is pretty pretty, right? What type of data is in buy box time? The buy box time right now is a date format. So it's the buy box time itself is a date time object. So it's a position X. It's like pos X. The class of it is this right here. Pos XCT, pos XT. So it's a time object. And so since it's a time object, you can do things to it like, say, the minute. And it'll literally tell you every minute something was bought. So we're just manipulating this right here to say, get us the hour from this date time object. And so we're just taking that vector of information right here and taking information out of it. And so, have some fun with the graphics. We're not grading the graphics too much. I mean, I wish we graded them more for how they looked. You'll work on that more in like Capstone, like making things look nice. Capstone is basically like the finishing touches to like make everything look nice and good reports. But we're more worried about, how to make this and handle the data. And then we'll worry about making things pretty later on. Could you create a new column that is assigned as, oh yeah, total. Watch this. Let's do that. Let's go here to buy two. And if you wanted to go to like hour, let's go hour bought. And then let's go here, go hour, boom. And minute. You can just do all this right here. And you are now adding on these columns. If you look right here, you can see we've added on the week bought, the minute bought, the hour bought. Oh, is there? I was about to say there better be weeks there. Then use as a factor in the yeah, you could just turn that column. Yeah. If you wanted, you could just go here to like the year something was bought. And here, let's change it. But no, this is how you could easily, and you could also just use it as a factor without saving it, but you could save it. And then if you want the year to be a factor, like if you're going to use it as like different like coloring groups or something, which might be, are you thinking like different, like to color the plots by certain things? Like if you had different years, and then you could make it a factor where it'd be in the legend, and you could select, is it only 2018? Oh, yeah, there's 2019. I was like, I'm pretty sure there's more years than 2018 in this. But so right there, you could save a new column, which is something we talk about a lot in this class. And so you could create a new column right there, and you could store it as a factor in that column. Just remember, you have to wrap it inside of a factor. Like, okay, I want this to be a factor. Does that make sense, Connor? Then I'm going to hop over to, let me see, is that 2D? Have we covered all the 474? We did a lot. We've done a lot of questions today already. I think I have to go to work soon. Can you put in something to go over the how to label the bar plots? Yeah. And I think hopefully Marissa's questions got answered right there. I think that'll help Marissa. And I think that's got it for 474 questions. We'll hop to some 320 questions. How's 474 doing? Last call 474. Last call 474. 320, I'm going to try to give some help. We'll probably stay a little bit longer today because I just kind of prepare for class and answer emails between the and answer Discord. So I jump around. Hey, Connor. Connor, are you here? You're going to get to hear something new and exciting. I'm going to give you some advice. You know what I want to tell you? This is so worth it. Check this out. You ready? Here we go. Wait, I can't see Connor's chat. You here? Here we go. No! Wrong thing. Tell my neighbors didn't hear me yelling. You ready? Here we go. In case you didn't catch it. Look, I'm done. That's my fun for the day. I need to just do it normally. Thanks, Jake. We talked about it in the last class, and I was like, we need to put that in here. Beautiful graph. Yeah. Okay, I'm done. Okay, let's get serious. Let's get swifty. Let's do it. Let's get serious. Okay, I'm gonna pull 320 right here. Throw a little break between doing some work. Relax, do some work. Connor knows office hours. We sometimes just relax for a moment. We take a break from working so hard, getting all the work done, and we just say, relax. Let's hop. I need to put the Dr. Disrespect, the DDR screen. It's made, yeah. Okay. So I made it. Crack me up. So, if you know, there's a streamer on YouTube or he was on Twitch, and one of his backgrounds looked like this. And I don't even watch him. I'd tell you if I watch him, I watch Philip DeFranco, and I used to watch Jenna Marbles, and she's taking a much needed break from the internet, I think. I mean, her choice and everything. So good for her for, being like, here's what I'm gonna do, and here's what I'm gonna do, and then doing it. But yeah, so I just look around what streamers are doing. So if you have ideas, literally that last soundbite came from someone just sent it to me, and they're like, hey Brian, here's that soundbite. And I was like, perfect. Thanks. Put it on my soundboard. Got it. So I need to go get the oof because we don't have that on our soundboard yet. So I keep talking about that, but then I get distracted. I'm distracted now. You know what we could do? We could go work on the assignment. Let's go work on the assignment. Okay, here we go. At the wrong screen. Look. There we go. If I double tap the button, it switches. For box plot, how do you find the outliers? Cool, Trace, is that 201? So Trace, perfect time to ask it. Let's see if people can help let's do this right here. Let's go to empty cars, and let's talk about how to find the outliers. Trace, 100 points. Thank you for jumping in and asking that. You're here. You get the question answered right away. Let's look at a box plot, and let's take a look. Oh, are there any outliers in this box plot? Are there any outliers in this box plot? The answer is surprisingly no. This is very, very close to having outliers. I'm going to try to find one right here that has outliers. Oh, there we go. We found one with outliers. Okay, so this is the horsepower of cars. So do you see the outlier? The outlier is right here. So the outliers are anything that are more than 1.5 IQRs above Q3 or more than 1.5 IQRs below Q1. And here I'm going to take this graphic right here and draw on it just a little bit, then we're going to do some 320 and go over time here in office hours, which is all right. Don't worry, we got time. And so what I'm talking about right here, let's do a little talk on box plots. Outliers will always be like a circle. You always see them kind of standing alone by themselves. Sometimes for extreme outliers, which we really don't do, but we mention it because people sometimes do it, is they'll put an extreme outlier with a star. So if you see a star, they're just saying that's really big outlier. So one thing you can do to know where an outlier would be is outliers, and this is a big review for 201, is outliers are always 1.5 IQRs above Q3 or 1.5 IQRs below Q1. And if you notice, we really don't have any data that, would be down here. There's no points that would be this low. And what do we mean by IQR? The IQR here goes from something like 48 to 175. I'm gonna make that really easy. I'm gonna call this 168. So the IQR is how much? How much is the IQR here? So how much is the IQR there? Oh, wait, IQR plus. Wait, oh my gosh. How much is the IQR there? And I just made up those numbers to kind of estimate. You are right. You're right. Trace, 100 points. I actually did it wrong in my head. I was thinking 80. Whenever I see an answer is not the one I'm thinking, I rethink it. And so, okay. So what is 1.5 IQRs? What is 1.5 IQRs? What would 1.5 IQRs be? And it looks in truth that this line would be a little higher. What would 1.5 IQRs be? Sorry, I was finishing up Q1, so I didn't ask if I'm just confused on the equation 2. Sure, Alex, we will do that. And you got it, Alex. We will do question 2 next. You got it, Alex. Don't worry, I'm going to stay over a little bit. I'm going to stay to like 115 or so. Then start preparing for 320. So what will be one? You're right, Trace. You're right. So notice how all we're going to do when we solve out like where we really don't go usually this in depth on the test. We usually just want you to know the equation. But if you were to solve this right here, you'd plug in 120, you plug in 120, and then you'd get 180 right here. So does this make sense, Trace, what I'm doing? I'm figuring out where the invisible fences are that we don't see. It's just where outliers begin. And I made the numbers nice for the example. Like I made up what the Q3 and Q1 are, just kind of like looking at the graphic. So 180. So now that you look at this right here, yep. And so now outliers would begin at, so if my graphic looks a little off, maybe outliers technically begin somewhere around like right here-ish, which should be about at 348. Is that right? So outliers would begin at 348. And then the lower bound is so lower that you wouldn't really see it. It would go to negative 132. So there's really no low outliers. And these invisible fences here are not something you see. You don't see these fences. As you notice, like if you go look at the graphic, they don't show you those fences. The fences are just to kind of tell you where outliers begin. And what does it mean that we have this right here? What does that shaded area mean? I have an appointment, need to go 2 p.m. I need to get some to our Discord. Yeah. Message me on Discord and then I'll reply between like classes. Sorry, Alex. And then I'll mention some stuff on question 2. I'll try to give some really good helpful tips here and hope everything goes well, Alex. On question 2, yeah, for the position, but there is a way to check, make sure the outputs are correct. I'll go look in a second. We haven't done question 2 yet. We'll talk question 2. You got it, Alex. Make Alex a mod right here. Alex, you are a mod. I think you just said it, Trace. There is no, oh, that was not Trace. I thought you were saying no data. There's no data in that shaded region. There's no data. So there's just no data. Like down here, that just means there's no data. So let's point to one last thing. This is the max. This is the Q3. This is the median. This is the Q1. And this is the min. If you're in 201, you should know these things instantaneously. And thank you, Trace, for coming here and asking questions. I do as many questions as we can. Always hop in, just say, hey, Brian, I got a question on this. And I try to bounce around between the classes I teach. And I'm even try to do more office hours because a lot of people are using this video. So I'm very glad about that, even though we just goof off and have fun. We really don't, I promise you. So let's go look at that 320. And Trace, if you have any follow-up questions, feel free to ask. Let's do this. Let's go look at that 320 stuff right here. 320. I'll go right here. Okay, let's look at that 320. Question 3, we can jump down to it like this. There we go. Oh, no, question 2. Not question 3, question 2. Okay, we're going to forecast. This is what we're going to do here is we're going to forecast for certain things. So I don't know what I'm doing. So we have a vector right here to start. The vector has the numbers 7, 12, and a random number. Did I add that in? Sure. Maybe I meant to add in a random number right there. Forecast of the numbers right here, and here's the equation. Now I need some 320 help. What does this look a lot like to you? When you see this right here, and I wish we were doing coding night still, because this question right here, if you know how to do it, it's like this. If you don't know how to do it, it's impossible. But 320, what does that look like to you? What does that look like to you? There's 3 things we need. And while you look at that, I'm going to go down here and start typing some stuff. The 3 things we need are the vector. Oh, Alexandria, you're right. 100 points right there. value, skeleton. So you see we have a vector, we have a value, and we found the skeleton. So now that we have the skeleton is the code. Great job, Alexandria. The code that repeats, and the vector is the values. No, it's variable. Haha. The vector is the values. The values, the variable goes through. Right on time. Yes, Ting Yang, great to have you here. And then the variable is the placeholder for what will change. Okay, let's identify. We have our skeleton. That code above. We have our skeleton. So we have our skeleton as that code above. Does anyone see the placeholder? It'd be a lot to write this code, but this, here, wait, just so you know, that's the skeleton. Don't include the quotes around it. So do you see the skeleton? Does everyone see the skeleton? It's right there. What is the variable? What is the variable? What is the placeholder for the thing that will change? What is the placeholder for the thing that will change in this code? And if you're wondering why this looks different color, I used a code to make it bold. If it were to print this to Word, that would now be bold, but it also really shows up here really well. You can do italics if you do this. You can go here and go italics. So that'll make things italics right there. T, great job, Alex, right there. Yep. So this, it's not actual code. It's like formatting for Word documents because we're not in a code chunk right now. Here's code chunks. We're in a Word document portion. So don't worry about knowing stars right here. That's Word formatting for if I were to knit this, just so you can see. I think this will knit. Will it knit? I just want everyone to know, like, wait, what are you coding, Brian? Oh, well, random's not defined. Random. Sure, let's go. Random, save into 2. Good. And now if you scroll down to that portion we're on and you go right here, there it is. Here's where I wrote T, that code above, and I just didn't put any spaces, but you can notice right here it's bold. And that is all I'm doing. So we only have one more thing to identify. One more thing. We got to find the question. Here we go. So with the one more thing to identify, the vector is n, I think. N is a vector, Alex. N is a vector. T is what will change, and we want T to go through certain values. So wait, something here, it says to fill in certain elements, the next 17. So when we first store into T, where will we store into in T? So look at the vector right here and look at the question. So when we first store into n, we will store into position what? As we go through and make this vector, when we store into n, we'll first store into position what? When we store into n, we'll first store into position what? I'm going to get really close to building this. Like, if you're following along, you will be like, got it. When we first store into n, we will store into position what? When we first store into n, it's on here somewhere. When we first store into n, we will store into position what? When we first store into n, we're going to store into position where? Where will we store into position? What position will this store into? And I don't like that as the equals. I want this. Close. That's the... You're right on... That's the vector. But the first time... It's for Alexandria. Great job, Alexandria, and great job, Alex, too. This is how we work together. This is how we be like, okay, wait a minute. The first time this runs, it's going to use position 4 right here, and watch this. Watch this. Should I sit here and do the full for loop? If I was faster. Oh, did I replace wow? Oh, they're both that. Oh, no. 2 seconds. Got to fix the soundboard. I can't have the soundboard have 2 look at this graphs. I think it's still wow now. Yeah, because it's got both sound effects on there. Top left. Look at this graph. Go away. There we go. Okay, soundboard working again. Now we only have 1 look at this graph. I meant to go wow. Okay, so take a look at this right here. What happens is each time I'm running this, it's adding on to it. So I'm actually doing the for loop manually. So as everyone see here, I'm doing the for loop manually. And just a moment here, we did the full for loop. Did I run? Oh, I didn't do 15. I think I'm fine. Oh, I didn't make a mistake. This is why you don't do this. This is why this is a bad idea. But you know what? We've gone this far. It's like if I didn't do it right now, you'd just be like, Brian, there we go. I think that's the right answer. As long as I didn't make an error, like I wouldn't run the code this way. This is not how you'd run the code. Because when this evaluates, it would just store to position 20. So if you had this, it would just get a bunch of NAs, and you can't even run it on position 20 because it doesn't have the elements before. But who right now, looking at this right here, has got this question in 320, looking at this, where it literally says, here's the vector you're going to go through as t changes. T is the placeholder, it's the variable, and then the skeleton is this code above. Any 320 people will be like, psh, I got it. I figured it out. Here's where this goes, here's where this goes, and this is what it's going to do. And if you watched, I was doing the code right here by going through, and T becomes 4 first, and then it runs, and this is the skeleton right here. So I'm kind of like doing the for loop without doing the for loop. I'm probably going to leave this as is. I'm trying to do more like questions that are kind of partially completed, so that way people have to like watch and be like, okay, where do I go from here? I want my goal is to get everyone really good at this kind of stuff. I saw you. The only thing I see from you, Alex, right now is a vector 4 through 20. Perfect answer. I mean, great job. Another 100 points right there. I mean, just like total. Because I mean, when I hit that sound effect, it only plays that. It doesn't play. We're just gonna see if I get a copyright claim on this video for a look at this graph. That'd be so sad if they copyright claim that literal 2 seconds because it's a popular meme. I think it's got it. How is 320 doing? This is a huge hint / help for this problem. Also, the theory right here is very important. This is also good help for 474 because they're going to have their almost assignment ahead of everyone, but they're doing a harder kind of for loop, while loop thing coming up. So if you're in 474, I might put this as like how to write for loop help, because I didn't finish this question. Let me feel here like question is not finished. So like use parts above to make for loop. Anyone in 320, and feel free to ask more questions. I know it's like the kind of end of office hours right now-ish, but if you have questions, ask. Question 2 makes a lot more sense now, and it helps with understanding what, yes, Alex, and keep asking. A lot of times, especially if you message me on Discord and we have a back and forth, I'll pretty much make sure you get to the answer. Like, you know, I don't, if we talk for like 34 minutes, I'll be like, okay, well, here's what you should change this, and this should be this. You're welcome. No, thank you, Alex, for hanging around. And thank you, Alex, other Alex right there, paying 100 points also. We'll probably head out here because I'll start answering emails, looking on Discord. But really good office hours. And we covered 474, 201, 320. And always remember, I do label these videos. So if you come back and you want to rewatch it, you will get to see what we covered throughout this. Alexandria, you're so welcome. You got it. What does it mean to be statistically significant? It means that the rule is unlikely by random chance. And that basically means that it's an actual rule that means something. So for a rule to be statistically significant, it means that the probability of this rule occurring, given that the rule, there's no real rule here, is unlikely. So a p-value is, sorry, this is a long time. What we would assume, let me put it this way. So the assumption with any rule, let's put this, we got this right here. Great question, Sean, 100 points. What does it mean for a rule to be significant? Statistical significance. Let's put notes right here. This is big for 320. So for 320, this is huge. Statistical significance means a p-value less than 0.05. So statistically significant means the p-value for the rule is less than 0.05. P-values tell us the probability of our results or results more extreme happening by random chance given the null is true. The null for this test is that the rule is not, the rule null for this test is that the association of missingness between the two is by random chance. And thus, when we have a statistically significant rule, we have evidence that the missingness pattern we see between the two is unlikely by random chance. There we go. So I also feel like maybe I didn't, it's kind of a review question from 201, 320, like what does it mean for something to be statistically significant? And it's maybe one of the harder questions because if I don't explicitly say something, sometimes I'll kind of halfway give away an answer. But this is, and Sean, thank you for asking that, because, I don't want things to be unclear, but that is kind of a, this should be a good review right here of what it means. Like, we're kind of starting out, like, what does it mean for something to be statistically significant? Well, statistical significant just means p-value below 0.05. What does p-value below 0.05 mean? Well, that means that the probability of what we saw or results more extreme happening by random chance was unlikely given the null is true, like of the probability. But if it's a low p-value, it was an unlikely probability. So then we have to know what the null for the test was. The null for the test was that the association between the missingness of the two is by random chance. So what does this mean when we have a low p-value and we thus have a statistically significant rule? It means that this association of missingness that we saw between the two variables, or the two columns, was unlikely to occur by random chance. It looks like in layman's terms, it looks like there really is a pattern to missingness here. Like, let's go, was it too long, didn't read version. It looks like there really is a relationship between variable 1 being missing and variable, I can't spell. Same variable 2. So that's kind of the TLDR version. It looks like there really is something. It looks like there really is a relationship between variable 1 missing and variable 2 missing. Like, variable 1 missing somehow is related to variable 2 missing, and it's unlikely by random chance. And we're starting to get into a longer version. I would just say, if my boss asked me, like, if it was like, tell your boss what this means, I'd be like, well, whenever we're missing low, it really does impact high. Like, I think it's not just random. Like, I don't think it's just random that we're missing high. I think when we're missing low, that somehow actually impacts high missing. Now, I'm not saying causes, but it's somehow associated or related to it. It doesn't cause it, but there's some maybe background variable or something going on that when we don't collect data on this one, we also don't get data on this one. I know I just talked as long as the other one, but usually I'll say things 3 times. Hopefully it helps people understand, because I'm a teacher. That's what I do. But does that do it, Sean? How does that look right there? Everyone good? This is what a rule being statistically significant means. Kind of a good review of it. And you're welcome, Sean. Yeah, anytime. Feel free to ask questions. Great job. I want everyone to ask all the questions. And especially if I make mistakes, tell me. No. With that, I need to extend this new outro. I like this new outro. I think it looks really good. I spent a lot of time making it and learning new things in After Effects. We'll check out the new outro here. I'll hop around. I'll answer questions. I'll answer emails. I'll be on the Discord. But I will talk to everybody later. New, quick outro. Talk to you later.